Alright, welcome to Chapter 10, quiz section on sections 7 and 8. First question asks for the sine of A, and before I would do anything, even tackling any of these, I would write on the side here, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So, ka, toa. Okay, so now we are asked for sine of angle A. So in this perspective, we have to keep it to A. So we see that sine is opposite over hypotenuse. Hypotenuse is here, 2A. So if I want the sine of angle A, it's going to equal the opposite over the hypotenuse. So in this problem, it will be the opposite, which is 30 over the hypotenuse, which is 34. And because the directions say in lowest terms, ratio as a fraction, in lowest terms, I'm going to reduce it, and 2 over 2, so we get 15 over 17 would be my answer. Now the tangent, again looking at the fact that it is of angle A, so my tangent is the opposite, which I've already notated, and my adjacent, which is the third side that we have an adjacent meaning next to. So if I want the tangent of angle A, which is going to equal the opposite over the hypotenuse. So the opposite would be 30 over the hypotenuse, which is 16. And again, that number can be reduced, and we would reduce that in half to 15 over 8 would be the tangent of angle A. Cosine, our third problem, but notice in this problem it is not angle A, it is angle B. So now all of this changes. The hypotenuse will stay the same, but we have to keep the perspective of angle B. So 34 is still the hypotenuse, but this time the opposite is 16 because it's the side opposite the angle. So when we look at the cosine, and 30 is our adjacent, but when we look for the cosine, which is adjacent over hypotenuse, cosine of angle B is going to be the adjacent over the hypotenuse. In this case, the adjacent is 30, the hypotenuse is 16, excuse me, hypotenuse is 34, sorry, 34, and we must reduce it to 15 over 17. So the cosine of angle B will also be 15 over 17. Now let's move to page 2. Let's do this. No, that didn't work, did it? Sorry, I got to take that off. Sorry, let's move to page 2. Clear ink. There you go. Oh, page 2. Thank you. This is new. Alright, page 2 says use the triangle in diagram 1.2 for problems 4 and 5. It says find the value of x. Well, if we look at the sides of the triangle, we see that we have a leg here. We see we have a leg here, and then, or excuse me, that's the hypotenuse, and then we notice that we are missing the other leg. So we're going to use a squared plus b squared equals c squared. Okay? I don't know why that's writing. I can't do that. Let's see if this will. So a will be 1 squared. It's messing up. Sorry. erase this, and let's see if I can. So let's see if this will work. All right. So we have a squared plus b squared equals c squared, where a we will name x, b is going to be 1 squared, and c is going to be 4 squared. Excuse me, 2 squared. 2, the hypotenuse. So x squared plus 1 equals 4. Now we have a simple problem that we want to isolate the variable x, or x squared in this case. So we're going to subtract 1 from both sides, and we're going to cancel that. We're left with, and I'll write it up here, x squared equals 3. Now we still have to isolate the variable x, so it'll be important for us to know how to isolate x squared, and the way that we get rid of x squared is by taking the square root. And when we take the square root of one side, we must take the square root of the other. The square root of x squared equals x, and the square root of 3 cannot be simplified. So, in this problem, x equals the square root of 3. Problem number 5 asks for the tangent of b. Well, we need to remember that the tangent of angle B is going to equal the opposite over the adjacent. So this is in perspective of angle B. So the opposite is going to be 1, and the adjacent is going to be x, which we just solved for and found out that that is rad 3. So the opposite equals 1 over the square root of 3, which is the adjacent. We know that we can't leave radicals and fractions, or at least we can't leave them in the denominator, so we have to do what is called rationalizing. And to rationalize it, we want to multiply it by rad 3 over rad 3, which is a value of 1. So we haven't changed the numerical value, we're just changing the facade. So we end up with rad 3 over rad 9. Radical 3 times radical 3 gives us radical 9. And the reason why we end up with that is so we could simplify. Rad 9 simplifies to just 3. So our answer is rad 3 over 3. Let's see, here we go, this.